So what did we learn last class?
You can use the point just to find
But that's only.
Oh, no. If you're given, last class, if you're given the slope of an equation, and you're given the point that the line passes through, right? So we have y equals mx plus b, that's our equation of a line. So we're given the slope, right? We just plug in the slope for m, and then we use the point to figure out what the y-intercept was. Like we plug in the x-coordinate for x, the y-coordinate for y, and then we solve for b. So that's how we got the y-intercept. So this question is a little bit different because I didn't give you the slope though. I gave you 2 points, right? But if you have 2 points on your line, what can you actually calculate for?
You can.
Sorry, Anthony? The slope, right? If I have 2 points on our line, I can calculate the slope. So how do I do that?
You draw a graph, like
Well, I don't want to draw a graph, but how can I do it algebraically? Because that's why I give you big numbers. Do you remember the equation for a slope?
y equals mx plus b.
Well, that's the equation of a line, so we'll start off with there. Start off with there. Oh. No, I didn't. So first of all, we'll start off with y equals mx plus b because we want an equation of a line. But what do you remember what the formula for slope was? So we need to know what slope is.
Right.
Do you remember anything?
The rise of
Yeah, rise over run. Now how can we calculate rise over one? Rise over run. Jenny?
y2 minus y1 over x2 minus x1.
Good. So first I'm going to do delta y over delta x. Because I like saying delta. I don't know why. I just do. Delta y over delta x, which is the same as y2 minus y1 over x2 minus x1. Okay. So which we're going to choose for point 1 and point 2? Does it matter? I like to do it in order. So here I'll say this is so this is point 1, this is point 2. So as you have given the question on a test or whatever, as you write it out, write point 1, point 2 right above your coordinates. Okay? That way you can see what's going on. So here we're going to have x1, y1, x2, y2. So here y2 is negative 54, minus y1 is 106, divided by x2 is 12, minus negative 20. So what am I left with here? Well, negative 160. All over 32. So what's my slope?
Negative 5.
Is it minus 5?
Yes.
Did it work out nicely?
Yes.
Oh, what a fluke. Okay, so our slope was negative 5. So here we go back into our equation. So now we know the slope is y is equal to minus 5x plus b. Whew. A little bit hard work to get there. But now we're familiar with what we were yesterday. We got a slope. We don't know what the y-intercept is. So now we're got a little bit of dilemma here. How many points are we given?
2.
2.
Doesn't matter.
And you can check. Yay!
Yeah, you can use either one. And I love what Boo just said. I could use one to get B, and I could use the other one to check. Okay? So which one do you look at? Which one do you want to use?
The smaller. 12 and
Good. Right? You might want to choose, I mean, there might be a smarter choice for which. Yeah, no, is there something to clear up?
Yeah.
Okay. So here you might just want to choose a point where the numbers are easier to work with. So Megan suggested the second one.
Yeah.
So y there's negative 54, so negative 5, what's the x value? 12 plus b. So negative 54 is equal to negative 60.
Yeah.
So we're going to add 60 to both sides. So I get b is equal to 6. So therefore my equation is y is equal to negative 5x plus 6. So we'll do what Buddha said. I'm going to check this. This is how I'm going to check it. My x value in this other point was 20. So let's plug that into our equation. Y is equal to negative 20, negative 5 times negative 20. And my equation was plus 6. So y is equal to negative 5 times negative 20 gives me a positive 100 plus 6. So y is equal to 106. Is that my y value in my other point? Awesome. Okay.
I didn't do that. It was marked if I don't do that.
You don't need to do this other part to check, right? But you just have to research, you know what? Pretty much know that question. Right. This is what we're just looking for, minus 5x plus 6. Okay? If you're proficient with your calculators, it takes you like 20 seconds to plug that in. 5 seconds you have to need it. Yeah. Okay, any questions on this?
Although it doesn't know what y equals x plus.
No, it won't solve an equation for you. You do have to do some work.
They should make it an apple
Okay, so really, this was a whole other lesson that I just taught in 5 minutes. It's just an extension of how you get an equation from a line from 2 points. And all it is was you just calculate your slope. We have those 2 points, we get our slope, and now we reuse the information that we learned from a previous lesson of having a slope and a point to calculate our equation. Okay? Now we'll move to something new. That was nice.
Long question.
Oh.
Take one pass it back,
Oh,
please.
thank you. Well, was nice. Oh.
There are some things that are worth writing down, other things are not. They're not? You think so? Sorry, any extras? Any extras? Is there extras?
Yeah, this one.
Let's go one in the front. All right. So I think it was like 2 classes ago, 3 classes ago, 2 classes ago. We talked about Mr. Morgan's muscular gym and causes cool gym. They ran that membership, right? Well, one of them was not very happy with me. Because I'm teaching math. So you know what? Nobody came sign up with me. He says, you know what? Nobody came because you taught them this thing that, you know what? Morgan's gym was cheaper, and no matter how long they sign up for, you'll always be cheaper than me, or I was always more expensive because what did we see when we graphed the lines? It was parallel, right? When we're graphing how much you actually pay for each line, they stay parallel. So Cause's gym was always going to be more expensive. Well, then he said, well, you know what I'm going to do? I'm going to change things around. So he changed his membership fees. So he still charges that initial $40. Remember, you charge $40 a month, and you charge an extra $20 a month for using the gym. So he still has an initial $40 to sign up. but he's gonna charge $15 a month, right? But mortgage gym is, we're good, got all this business, gonna keep it. Initial fees are $20, $20 a month. That was a good deal, we'll keep it going. So the question is now, which one is the better deal? Which one is the better deal? Right? We have Causes Cool Gym, higher startup costs, $40, but every month I go, it's only costing me $15. Morgan's Gym, well, lower startup costs, only cost me $20 to sign up, but every month I'm going, I'm paying $20, $5 more than Causes Gym.
Well, it depends on how long you know.
So now it's no longer a straightforward question, right? A lot of what ifs, what depends. So we're gonna analyze this a little bit. So last couple classes, we said that mortgage must go to gym. The equation to figure out the cost for that gym. You okay there, Mike?
Yeah.
So the equation for figuring out the cost to go to mortgage must go to gym was the cost was 20 times the number of months that we actually go plus 20, right? So 20 was sort of like our slope, that was the monthly rate. Now, what's going to be the equation for causes for gym? Oh, what equation do we get from that now? How can we sort of figure that out? D?
Can I say the equation?
Yeah.
C equals 15 m plus 40,
And how did you get that so fast?
because 15 is how much you pay a month,
Yeah.
M is the number of months, and 14 is the starting price.
Yeah. Good. So 15 was sort of like a rate, the thing that causes our cost to change all the time, right? So every month we go, we have to pay an extra $15, $40 initial cost rate. So what I want you to do is on this graph, I want you to graph these two equations. Okay? So the first one we want to graph is mortgage. So take that, graph how you think you need to, I'm going to do it up here, I'm going to do both of them. Well, if it's 1 month, how much would it be? Right? Or, what did we learn? Well, what's the y-intercept for this one? Y-intercept here one was 20. And what's my slope? My slope is 20. So every month I go up, it's 20. Right? So here I draw my line. So there's my line for mortgage gym. Now I want to graph causes cool gym now. The y-intercept, for his starting value, there's 20. So now for every month it goes up, I go up by 15, which is going to be a little bit hard by my scale. So every 2 months, how much does it go up by? 30? So that might be a little bit easier for me to do. Okay, so try your best to graph both of those lines. The first one's a little bit easier. Second one's a little bit more difficult, only because the scale, I went by 20 on the vertical scale. So it's hard to map 15 in there somehow. But try your best. Yeah, because to me, every 2 months cost 30. It was a little bit for me to see at 30, as opposed to trying to get 15.
Yeah.
Does everybody have those 2 lines? The 2 linear equations? Well, I like your double colored or quadruple colored. It's 55, it's 70s, and then the next one should be 85, and then 100. Okay, is there a slogan?
I have on that.
Okay, make sure you draw that with a straight line all the way to the okay? Yeah, as long as you guys set that straight.
Think about it.
Yeah. Okay, so everybody got their graph? The 2 graphs? So this is the hard discussion right here. Okay. First one's kind of easy. These 2 lines do cross. I know they will cross because first of all, the slopes aren't the same. As soon as the slopes are not the same, your 2 equations will always cross somewhere. Right? At some point, somebody's going to catch somebody else because they're going at a different rate. So the question here is, where is the point of intersection, or where is the line meet?
Over 100.
At 100? So what's the coordinate here?
104. We don't
Well,
have-
isn't that the coordinates here where it meets? Right here is really it's 4, 100. Right? That's where it's actually intersecting. Right? We look, I hope you drew it like this. It intersects at 4, 100. That's where it's crossing. So really it's at 4, 100. So that's the coordinates that intersects at.
Dude, because this needs to start.
Okay? This is the key point here, this key question. What do you notice about this point of intersection? Yes, it's where the lines meet visually, but conceptually, what do you notice about this point of intersection? What does it actually mean? What does this point of intersection actually mean? Sorry? No? Well, in general, but here you can use this example to help that generalization. What does it mean when these 2 lines conceptually mean when it crosses this point?
They're both paying the same price.
They're both paying the same price. What does that mean though?
Like both.
So what value is the same? So Dean's right.
The cost is the same, yeah.
Good. So here, at this point of intersection, C is the same. Right? No matter which line we're looking at, C is the same. In other words, the cost is the same. That's only half the answer. Say again, Megan? Right? Because we have 2 points. We have the points, 2 coordinates. So here was the C, this was the M. M was the same.
Oh,
Right? So where across that line, M and C was the same value for both equations. So at Cause's gym, at 4 months, we paid $100. At Morgan's gym, at 4 months, we paid $100. Right? When M was 4, when the month was 4, cost was 100 on both of those equations. That's what the point of intersection, where intersect really means. That's where x and y values are the same for both equations. And we look conceptually at our lines, where it's meaning, yeah, we see that. X and y is the same for both of them. So here, this is what we call sort of like the break-even point. Okay. Break-even points. I don't know if you guys learned this in business yet. You'll probably eventually. It's the break-even point. So this is how we answer the question. Which membership is a better deal? So which membership is a better deal?
cost is 3 things.
Jenny? So if I go to the gym less than 4 months, 4 months or less than 4 months, then this one here is the better deal. But if I go to the gym more than 4 months, which was the better deal? Yeah, this one here becomes the better deal after 4 months. If I only go to gym for 4 months, which is the better deal?
No, neither.
Doesn't really matter. In the end, I still paying $100. Now, what happens after this math class? We're going to go walk up the sides of the fool's gym. Okay? So what do we know about the point of intersection? Is that our independent and dependent values are the same for both equations. That is x comma y is the same. Okay? So what we're talking about here today is important for next year, grade 10. It's actually quite important for solving things like this, when we talk about relationships between 2 equations. What we're talking about is, well, first of all, the first main point is the point where 2 or more lines cross is called the point of intersection. The first key concept we need to understand in this lesson. The point where 2 or more lines cross is called the point of intersection. For 2 lines? So you have 3 lines, then you will have, you got possibly have 2 points of intersection. If you have 3 lines, hopefully what you might look for is actually where all 3 lines cross at one point, and that's sort of important. But you might have 3 lines, you might have a relationship where they're crossing at 3 different points, and those are important as what you really do there, Nicholas, is you're taking each three. So if you have your three lines, you compare from like two of the three, and you find a point that is intersection for each of them. So you take line 1 and line 2, line 1 and line 3, line 2 and line 3. And you do this over and over. So a linear system, I should have bolded that. A linear system is two or more linear equations considered or examined together. So what we just looked at was a linear system. What was it? What was it? I'll get to there. Okay, I meant to drag it down and run through it all at once. So a linear system is two or more linear systems considered or looked at together. Finally, the solution. So we talk about solution. Another word for solution can be new to you, but it's going to be used often in grade 10. It's called roots. Don't ask me what it's called roots yet. This is called roots. You need to know that. The solution or roots of a linear system is that point at which the graphs intersect. Yes, so your solution is your point of intersection. So the coordinates of a solution must satisfy, and there's that word again, satisfy, that is make it true, satisfy both equations, that is make both equations true. So if we go back to that previous example, when C is 4, right, what happened to in 100? So look at 4 and 100. So that makes Morgan's muscular gym equation true, right? Well, what C was 4 was the cos 100. Sorry, what the month was 4 was the cos 100. Yeah, 4 times 20 is 80 plus 20 is 100. When the month was 4, the causes gym will come out to be $100. Yes. So that coordinate, 4, 100, made both equations true. Have you done with this slide?
No.
Okay. Okay. So I'm going to show you something that's really neat. You won't find this in the textbook.
Anything.
So here we have our two equations again. Morgan's muscular gym, C is equal to 20m plus 20. That's cos is gym. That equation was C is equal to 50m plus 20. 50m plus 40. So just first looking at our two equations, what do you notice? Powers of observation. What do you see in terms of similarities? In format, good. What else? Bits?
Y equals mx plus b.
Right, so y equals mx plus b form. Yeah. But specifically looking at this, what do you see? Numbers. But there's a similarity there. There's a similarity there. It's almost like staring you in the face. It's so obvious you would kick yourself You know, think of it and I tell you what it is. You can say, but Mr. Town, that's so obvious.
It's same grade. Well, it's the same grade.
Yeah, close. Paul?
They both have starting costs.
Okay, they all start because
None
of
of them
2040.
started the origin.
Yeah. But what's the similar, what is the similar? Anthony? Same format, yeah. You guys getting close. There's a similarity, it's like it's staring us right there.
Oh, you're trying to, oh, they're both equations for C?
Oh yeah, those C on one side.
Yay!
Yay! Right? I mean, it's not, right? C is on one side. C is equal to that, I know. But here's the thing that we can derive from this though. This is the cool part. Well, C is equal to this, and C is equal to that, then we must know that 20m plus 20 must equal 50m plus 40. Right?
No. Not the same.
Yes? We said that C is equal to this,
Yeah.
but C is also equal to this.
They're different C's.
No, we're talking
It's
about
on the
cost.
same graph.
Talk about cost.
Are they positive?
So we said C is equal to this. So what we can say is because C is equal to these two things, they're actually equal to one another. Watch. Okay? But do we kind of understand that? Right? We see C is equal to this, C is equal to that, so this is equal to that. Now when you do, I have an equation with how many variables? One. So what do you think I can do for it now? Solve for it. Well, I'm going to subtract 15m from both sides. And I'm going to subtract 20 from both sides. So I get 40 minus 20 over here. So here I get 5m equal to 20. Right?
Yeah.
So 20m minus 15 is 5m. 40 minus 20 gives me 20. What's m? 4.
And that's the x value of the
Whoa.
point of intersection.
Do we not see that m was equal to 4 at a
No.
point of intersection? Well, we only got m. We know that m is equal to 4. Well, we plug that back into our equation. Which one?
Either.
Because at that point is when those 2 points are equal, we know that c and m have the same value for either one. So here we feel that that value for m is equal to 4 for the value is 4 for m. Then we calculate one for c. So here I just pick the first one. 20 times 4 plus 20. C is equal to 80 plus 20. C is equal to 100. So therefore, the solution is 4 comma 100. In other words, this was our C value. Sorry, this was our M value. This was our independent variable, and that's our dependent variable.
Wait, why did you go to 100 minus 17?
Why did I go to 20 minus 15?
Oh, never mind.
So here, this is how you can solve for your system, your linear equations algebraically. Which, I just taught your first lesson at grade 10. But what I want you to draw from this is that connection where the lines intersect, and all you're doing here is you're just finding where that one point is, where the 2 lines intersect. That's all we're doing. Don't care about any of the other points. Just that one single point where the 2 lines intersect. This is what we're doing. This is how we can find that one single point. And only that point. Okay? Are we preparing this down?
Mm-hmm.
Yes, Nia?
So you could plug 4 into either one of the equations, so
Yeah. So here I could plug 4 back into here. What's 4 times 15? 60 plus 40, gives me 112. And in fact, I teach my grade 10s. That's how you check you actually got the right values. You go back and you plug into your equation. So we're done? Okay. So here's a question. We're just going to do this graphically. Solve this linear system by graphing. Okay? You know, I think this class ends at
Like a normal time.
Do it algebraically if I'm too lazy to graph.
no, you have to graph.
What?
11:35?
What's the point of running it algebraically? But the entire point of running it algebraically is to make it easier.
So do you see it? I won't go into that, Paul. You just need to do it graphically. Sorry? I think it ends at 35. Well, you know what? So if we want to graph 1 and 2, how can we do this quickly? Well, go back to a few lessons. We can convert this into y equals mx plus b form. Does that take us a little while though?
Yeah.
Yes. I know, life is so hard, making you write notes. Good thing we're not in a prison camp or anything like that. Because that's just
I can't see past this circle. Is it 4x minus
4x.
3y?
here's the first equation, here's the second equation. So one way to quickly graph our equations was, remember, we're doing intercepts. Right? So for number 1, the x-intercept. That means y is equal to 0. So we get 3x minus 6 is equal to 0. 3x is equal to 6. X is equal to 2. There's 1 point. My y-intercept. That's when x equals 0. So I get minus y minus 6 is equal to 0. So y is equal to negative 6.
Why'd you say?
Sorry?
Why'd you just take up all the
We're proficient now. So I have to draw my line. Yeah, because I'm plugging in 0.
Yeah, that's what I said.
I'm getting my intercepts. Right? That was a few lessons ago. Remember, graphing my intercepts. So if I draw this line over here like this, you guys should be able to draw much better lines than I can. Something like that. So that's the first line. The second line, my x-intercept, the y is equal to 0. So there I go, 4x, y equals 0. Because that's what the x-intercept is, right? Y is equal to 0. So here 4x minus 4 is equal to 0, so 4x is equal to 4, so it's equal to 1. So here. Where? Here? Because over here, when x is 0, I get 0 minus y, I have a negative 1.
Oh, so did you just find it by?
Here I added, yeah, I added y to both sides and I put them in one step. Sorry.
How did you get equal 6 to y?
I added 6 to both sides and then divided by multiplied by negative 1. Let me add this. Let me add this next step. And that'll give you negative 6. Sorry. me a positive 6. That gives me a positive 6, and then divide by negative 1 So here my y-intercept, when x equals 0, that gives me negative 2y. Is that negative there? Minus 4 is equal to 0, so negative 2y is equal to 4, and y is equal to negative 2. And there's my other point. Okay, so really what we're doing is you're taking two equations and you're graphing them. This is why it's important that you have a straight edge. So you draw your straight lines. And you can see exactly where they will cross. You can never cross more than once. Yes, sir. Yes. So in other words, for this first one, when y is equal to 0, so I end up with 3x minus 6 is equal to 0, making x equals 2. So 2 comma 0, because the y value is 0, right? Now the y-intercept is basically when x equals 0. So I get negative y minus 6. Then I add 6 to both sides, so I get negative y is equal to positive 6. Divide both sides by negative 1, so I get y is equal to negative 6. So that's how I get my other point, and then just draw a straight line. And I did the same thing for the second equation. So it looks like my point of intersection. This is why it's a lot better for you guys with your rulers and your pencils. It looks like, does it cross right around here? 5 comma 7? Or is it 4 comma 6? That's the drawback if you try to do this on a smart board.
I think it's 4 comma
You guys
6.
don't have graph paper.
Mr.
Well, Leanne still has graph paper. It's important that you do this on graph paper.
It's 5. It's 4 comma 6.
Is it 4 comma 6?
I did it algebraically, it's 4 comma 6.
Okay, so how we can quickly check for this? We just gotta plug 4 comma 6 into one of our equations, or both of them. So 3 times 4 minus 6 is equal to, so that's my left-hand side. Right-hand side, that's 0. So that's 12 minus 6 minus 6.
Oh wow.
So that's 0. Right? So that was for this. I checked over here. Now I'm going to check for this equation down here, left-hand side, right-hand side. So we get 0 there. We get 4 times 4 minus 2 times 6 minus 4. So that's 16 minus 12 minus 4. That gives me 0. Okay, so that's how you can check that your answer is correct. By plugging in your x and your y values that are the same, so it's for both equations. Going back, and does it solve? Does it make each of our equations true? And then just check that right here. This was the first equation. We may check that it was true. And over here for the second equation, we also check that it's true. Okay? So that's one additional step you can take to verify your work. Okay, wait like 7 minutes. Thank you. Okay, any questions with this? I guess Steve will do 2 more examples because they're pretty important. No? Let's not go there. Okay, can I come back to this later on? Okay, so now we have two other equations. I'll quickly do this. This one's first one simple to graph. Right? -7. And my slope is 3. So up 3 over 1. Up 3 over 1. My graph is going to look like this. Okay. So the second one I can do my intercept trick again. So y-intercept, x equals 0. I get -2y plus 4 is equal to 0. -2y is equal to -4. So y is equal to 2. And then for this other one with x-intercept, that means y is equal to 0. I get 6x. Oh, that's not going to work out nicely. 6x is equal to -4. X is equal to -4 over 6. So x is equal to -2/3. X is -2/3, which is roughly around right here. Let's draw this line.
They're parallel.
So you're gonna notice. Yeah. What I could have done is I could have worked this algebraically. This is really 2y, 6x plus 4. Y is equal to 3x plus 2. What do you know about the slopes? They're the same. So when we're getting two equations with the same slope, we have no solutions. That's what we're trying to demonstrate here. Okay? I won't bore you with this one.
So wait, Mr. Tim, how would you finalize that answer? So equation
There's
one
no
is
solution.
there. You write that like there it is.
You should have done it in grade class. Did you see that? We write to no solution.
Because the slope is the same, they're parallel, they won't intersect ever.
They're parallel?
Yeah,
They're
they
parallel.
have the same slope.
But aren't they gonna make it look
If I work this out, if I put this into y equals mx plus b form, I get y is equal to 3x plus 2. They both have a slope of 3. So they'll never intersect.
That's because the lines aren't that straight.
Yeah, that's the way I couldn't draw it. Yeah, they'll never cross. They'll never intersect. Well, they will never intersect. That's why they're supposed to. This last one, if you actually graph it, this is what you get. -6. The slope is -3. So this is the black line. Now let's graph the red one. It looks exactly the same.
So any point is an intersection.
So basically we have two of the same lines, two equations. So this has infinite solutions. So this is the point you need to write. So parallel lines have no solutions. Parallel lines have no solutions as there's no point of intersection. Parallelize on those solutions that there's no point of intersection. Finally, equivalent lines have infinite solutions as there's the same equation. In other words, there's infinite amount of points that they're intersecting at because they're the same line.